last video we talked about the B class pump. So today we are moving to the next class of pump, which are termed as F class pump. Although these are not pumps in true sense, as in they are more like generators. That's why they are called ATP synthase. So they use the flow of proton across its gradient across a membrane to generate energy or generate ATP. Here let's consider this membrane. Let's say it's the inner mitochondrial wall. The proton will flow from higher concentration to lower concentration across this membrane, and this complex will use it to produce ATP. It is composed of two multimeric components called F0 and F1. Now, looking into the details of each component, the F0 component, it is made up of three subunits, all of which are integral membrane proteins, which means all three of them are embedded into the membrane. Here let's say the mitochondrial inner membrane or any lipid membrane, and in this subunit, the C component, the C ring, is the one which rotates, and this is the important component of this. We'll see how it affects the energy production. Let's first see that the F1 subunit component has 5 subunits: alpha, beta, gamma, delta, and eta. Sorry, epsilon. Now this, okay. So these proteins or these subunits, they are all soluble. So they are present towards the cytosolic or the lumen of the mitochondria. So now, before we go into the structural details, let's look at how it functions. So the gamma subunit of the F1 component is a coil structure which allows it to enter into the C ring. So I'll show you how the C ring looks like, which is composed of multiple C subunits. Now as I've already told, all these blue bars are the C subunit proteins. Then there is A, which connects it to the B subunit, which is also acting as a SAPT, which is connecting both F0 and F1. And when the C subunit rotates, the alpha beta rings also rotates, as they are connected through this gamma subunit. And thanks to the coil structure of the gamma subunit, it can get inserted inside of the space between the C ring. Now let's consider a situation where the H plus, the proton concentration, is higher outside the membrane as compared to inside. Okay, so the proton will try to pass through this C ring to enter into the cell along its concentration gradient. Now this causes a conformational change in the C ring and it rotates. Now as the gamma subunit is connecting the C ring to the alpha beta ring, they also rotate along with the C ring. This helps in bringing the ADP and inorganic phosphate close together inside the alpha beta ring to produce a ATP. We'll look into the details of how this happens. So there are 3 states of this alpha beta subunit when they are rotating, and we'll also look the molecular detail of it. So the first state is O state, which binds poorly with the ATP, and it binds weakly, or let's say a little better than poor but still weak interaction with ADP and PI, the inorganic phosphate. Now the next state is L state. When the ring is in L state, it strongly binds with ATP and PI, which means it has captured them and kept them together. Now, in the T state, the last state, the binding becomes too strong. A tight interaction which brings the ATP and PI close enough for them to react and become ATP. Now this reaction derives its energy from the flow of proton ions along their concentration gradient, making this reaction spontaneous. And once the ATP is formed, the state reverts back to O state and ATP is released, because in O state, as I've stated already, the ring binds poorly to ATP. Now we can go and look into some of the molecular details. Okay, so here is a structure of the 12 C subunits and 1 A subunit. This structure was obtained by NMR from the Escherichia coli F0 subunit. Now from a side view, you can see all of them are alpha helical structures, because of which they are easily embedded into the membrane. And the A subunit is on the side, which connects to the B shaft, and then the C subunit is forming a ring-like structure with a pore inside, which allows both hydrogen, the proton ion to pass, and also the gamma subunit to enter. And here is the F1 subunit along with its all the components. Here you can see the alpha and beta ring at the bottom, which rotates along with the C ring, and in the green we have epsilon and delta, and in the dark green we have the gamma subunit which enters into the C ring, and I'll show you how they look when they are rotating also in an animation video. Here is a simple animation made by capturing the F1 and F0 subunit at different states, and here it is upside down, so the bottom one is the F0 and upper one is the F1 subunit, but you can still appreciate how the rotation of F0 is inducing a change in the gamma subunit conformation, causing a rotation in alpha beta ring. And this is what finally helps us generate ATP from the proton gradient. Now, this is one of the most studied and well characterized protein because of its importance, and it's one of the really well studied molecular machine.